Assalamualaikum and hi, my name is Muhammad Adi Haikal bin Zainuddin and my metric number is MA18179. So now I will present to you the introduction of this project. Freefall, as first discovered by Galileo, a free-falling body undergoes uniformly accelerated motion in close proximity to the Earth when the air resistance is negligible in relation to the weight of the body. The amount of acceleration of freefall is G equals to 9.81 meter per second. Okay, for the final speed of free falling body depends only on the weight which has fallen, as shown. The formula is V equals to plus square root 2gh. For moment of inertia, the behavior of all bodies in retaining the state of rest of or a uniformly straight line movement is caused by property of the body's term inertia. We therefore refer to this behavior as the law of inertia. According to the Newton, the law of inertia is defined as stating that any mass point remain at rest or in state of uniform movement on a straight path as long as no force are acting on it. Okay. For this, as in our experiment, the moment of inertia is shown as below the formula. J equals to 1/2 dot m dot r squared. Okay, for the acceleration is calculated as follow. A equals to m dot g dot sine alpha dot r squared over j. Okay, that's all from me.
Assalamualaikum, my name is Muhammad Adi Jeffrey. I'm metric number MA18025. And today I'm going to present about methodology and original experiment setup. So for the original experiment setup, that's using two apparatus, that is TM611 rolling disc on inclined plane. So in TM611, there is number one, two carriers with 3-point bearing, serve as the inclined plane. And number two, a height adjuster to adjust the angle of inclination. And number three, an angulometer to gauge the angle of inclination. And number four, a meter stick to gauge the distance. And number five, two discs self-centering by means of conical shaft journals. And number six, three bubble level for precise alignment. And number seven, a pendulum support. And number eight is base plate. And number nine is roll. And second apparatus is stopwatch to calculate the roll data. So for the experiment procedure, test one, inclined plane. Firstly, set the desired inclination of the inclined plane. Secondly, using the meter stick, select the desired distance between 0 to 1000 mm and prepare a stopwatch. Place the desired disc at the 0 position on the track. Make sure the midpoint of the rotational axis is located at the marking and the disc is positioned in the center. Let the disc go and start the stopwatch. At the end of the desired distance, stop the watch and the disc. Make sure the watch is only stopped when the midpoint has reached the measurement mark. Repeat the measurement procedure several times in order to minimize measurement error. Then calculate the mean value for each series of experiment and put the result in the tables. For test 2, pendulum support. Firstly, the pendulum support and base are aligned. And second, a box level is attached to the base plate to assist in leveling. The star grip screw is turned until the bubble in the bubble level is exactly in the middle. Then star grip screw are locked with the nuts. Slot the straight pin supplied through the disc which is to be swung. Slot the disc into the pendulum support, swing the disc and time a certain number of oscillations such as 10. And lastly, based on time, the mass and distance from the center of gravity, calculate the moment of inertia and put the result in the tables. So that's all for me. I'm gonna pass to another presenter. Thank you.
Hi, Assalamualaikum and Bismillahirrahmanirrahim. My name is Masita Fitra and my ID is 19053. So for this experiment rolling disc on inclined plane, I will explain to you how the experiment will carry out. So for the test 1 inclined plane, I will show you how to do it. So let's go. So here I have my stopwatch with me And now I have set up the desired inclined plane. So what we're going to do is release this ball and record the time taken for ball reach the end of inclined plane. Now let's start it. 1, 2, 3. So the time taken for ball reach down there is 3 seconds and 10. Now we repeat with the small ball. As you can see, I already marked the center. Now let's put it here where you can see the center side here and side here. So let's start our experiment and record the time taken for the ball reach at the end of inclined plane. 1, 2, 3. So the time taken for the small ball reach at the end of inclined plane is 2 seconds and 43. Now we have done the test 1, is the rotating disc on the inclined plane. Now we can forward to the pendulum support, test 2. Okay, now for the test 2, support pendulum. I don't have the really actual pendulum support, so I'm going to get creative with it. So here I have 2 rubber band and thread that I have tied together. Now we wrap this rubber band around the small ball that I have used for the previous test. Let's see how it goes. Now I just wrap one and the second wrap to make it more stable. So this is the finished product that I will use for our pendulum support. This is for the small ball, and I'm going to use the same technique as the same big ball. So this is our setup for the pendulum support. At my hand right now, I'm using the small ball. So what I'm going to do is take the time taken for 10 oscillation for the ball. Now 6, 7, 8, 9, 10. So the oscillation time taken for the 10 oscillation is 40 seconds and 10.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Arif bin Yusuf. My number ID is MA19050. Today I'm gonna present the result and the discussion for rolling disc on inclined plane. Okay, first we go to the table 1. There is a roll time for a distance for 1000 millimeter. Okay, for this it has two. There is a large disc and small disc. For the raw data, we have a T1, T2, T3, and we find the T average. We got the T mean for each angle, and it's similar for the small disc also. And then we go to the table 2. There is roll time for distance of 1000 millimeter. Okay, this is for to find the acceleration, calculate time and deviation. Okay, for the acceleration, we use the formula that has been prepared in the lab sheet. And then we got the acceleration for each angle for the large disc, and we got the calculate time. For the deviation, we just calculate measure time minus calculate time over calculate time times 100, and we got the percentage. And next, we go to the table 3. There is a small disc. We got the acceleration by using the formula, and calculate time also we use a formula, and we find the deviation for each angle. Okay, next we go to the experiment 2. That is, we use a pendulum beside the inclined plane. Okay, we get the raw data from the experiment. There is T1, T2, and T3. And we find the T average for each large disc and small disc. We got the T average, that is 13.59 and 13.47. Okay, then we use this time to find the omega, and we got it. And then we find the moment initial using the omega. Okay, next we go to the discussion part. That is rolling disc on inclined plane. Okay, this question we got from the lab sheet. This question have 13 questions, and we answer the question. Okay, that's all from me. Thank you.
Hello, my name is Muhammad Adi Iskandar bin Saidi. My metric number is MA19046. So I will continue present about the conclusion. for the conclusion, from the experiment, we can conclude that if the mass is bigger, the angular acceleration is higher. As the degree of inclination increase, the time taken to roll down the disc is decreased. The experimental angular acceleration of the rolling disc can be calculated using a simplified kinematic equation and the summation of moment using mass moment of inertia. The theoretical angular acceleration was calculated based on the finding of an experiment in which the disc was initially at rest. The most significant inaccuracies are produced by incorrect selection of the roll's starting point and frictional effect at the contact sites. We also know from the experiment that the angular acceleration is constant and that the angular velocity increases as the disc rolls down. If the error source is ignored, the mass moment of inertia by rolling and the mass moment of inertia by pendulum is successfully computed in this experiment. That's all from me. Thank you.